trying to say chromatography, there's several different types. There's paper chromatography. There's something called thin layer chromatography, and there's column chromatography. This one, the paper chromatography, you might have ended up doing like in elementary or middle school. It's a real common one where they'll take like a coffee filter and like Skittles and put it in, you know, get the Skittle wet and then watch the ink go up or dye go up the coffee filter. Sometimes they'll do it with like Sharpies and alcohol with the coffee filter and make that happen. All right. So paper chromatography, this is the most common type that you'll see on the AP exam. I've never seen the other two, but they do mention them. So that's why we throw them in there, because it might happen. The way you would do this is you would draw a line here where your ink spot is, and you're going to draw that typically in pencil because that's not going to move. It's going to stay right there. It's not mobile. Drop the sample on there, and then you're going to put it in some sort of liquid. Sometimes they make it polar, sometimes they make it non-polar, so you have to pay attention to that. And then they watch how far this goes up. Before it hits the very edge here, they will pull it out and they will draw another line. And that will indicate how far the solvent went. So if the solvent continued to climb up into here, they would mark that, and that would be the solvent front. And then they would measure how far each dye moved from the original line that was drawn down here. They then do a ratio. They do a ratio of how far the dye moved over how far the solvent moved. If this is a polar solvent, this would be the most polar dye because it's going to stay with the solvent and move with the solvent the furthest. If this is a non-polar solvent, then this would be the most non-polar dye. It's going to move further with that. Does that make sense?
So the most polar is the highest number.
If the solvent down here is polar, okay? If the solvent down here is non-polar, then this would be the most non-polar. That make sense? So you have to analyze and see what solvent this is and if it's polar or non-polar. And then you could base which dye, you know, which one of these would be more polar or non-polar based on that. So this is what I mean by the solvent front. They're going to allow this to move up through here. They would stop it and pull it out at this point. You can't continue to let it go up and over because then you don't have a frame of reference. So the same compound will move at the same rate relative to the same solvent trial. The more similar the polarity to the sample and the solvent, it's going to travel further. Polar water will have polar samples travel further. Non-polar samples will travel less. Non-polar benzene, it's going to be just the opposite. And then we can calculate this RF value and compare how far those dyes go. So that's paper chromatography. All right, and you're going to do like an online simulation with this to get familiar with how to do those RF values. You're going to do that this weekend. Thin layer chromatography then is, I've never actually done this myself. This is more of a college level kind of experience. It's similar to paper chromatography, except this time it's usually done on, instead of on paper, it's done on a thin sheet of plastic. And then layered on top of that is like a silica or something that is extremely polar. And so when you do this thin layer chromatography, they're going to separate some of the samples, and but you can't see them always. So sometimes you have to go through a process where you develop them. So anhydride would be an example of something that they would use to develop this with. Again, I've never seen this on an AP exam. When you analyze it, the rate of the compound will move at the same rate of the solvent. Different compounds will have at least slightly different polarities, and your RF factors then can be determined from that. The more nonpolar the sample, the farther it travels here. And that's every time because they have put a polar substance on the top of this. So the paper or the plastic and the silica on top is polar. So this isn't as retrospect to the solvent it's in. It's more about the polarity of the layers. So this one's in every time. The more non-polar it is, the farther it travels every time. The more polar the sample is, the shorter it travels. It's going to be attracted to that silica and not want to move up with the solvent. So the silica, the paper itself, is going to be more polar than the solvent that it's moving up through. So it'll be more attracted to that paper, or the, not paper, but the layers, the material, the medium, than it will be to the solvent. So the more polar it is, the more it's going to stay down towards the bottom.
So it's like the paper's polar?
It's not paper, it's plastic with stuff on top of it. And that is polar, yes, extremely polar.
And so if it's polar, it's attracted
to that, and it doesn't want to climb with the solvent. It wants to stay back on where it's at.
And it doesn't want to move.
Right.
So it stays.
Mm-hmm.
Okay.
All right. So here, column chromatography then, and I had never, like, I had never even taught this until this year, and it's not, I've never seen it on an exam, but they had it on their notes, and so I thought I'd throw it in. This is one that, and I don't remember ever doing this in college either. So, but they talk about the methodology behind this. This is the steel wool. It's placed in the bottom of your burette to keep the stuff from going through. And then they're going to put different stuff inside here. They've got a polar silica gel in here, and the mixture is going to be placed in here. And so when the mixture is placed in, the stuff that's least polar will move through here faster, and you'll grab that stuff first. And then you move that off. And then you grab some more, the next stuff that's a little more polar until you've finally collected it all. And there's a video that I'm going to have you watch about how to do this. It's that Professor Dave. You've probably watched him in some of your other classes, maybe. It's only like 8 or 9. I don't even know if it's that long. It's only maybe 5-minute video. So, but the most polar parts of the mixture will travel slowest, and the least polar will travel the fastest. We've already talked about distillation, I believe. I pulled up a distillation apparatus. That's another way to physically separate mixtures of liquids, where they have, it takes advantage of the different boiling points. So when you have one of these substances, a mixture in here that has different boiling points, you can heat it to where one of them boils, one component boils, but the other one doesn't. And then you can condense that back over here as a liquid. So applications of distillation, fermented beverages, desalination of salt water, crude oil into fuels. So when they get it in, that's what the refinery essentially does, is when it gets the crude oil in, it will separate based on the different boiling points of that, the different components in the crude oil. And the ones that boil at the lower temperatures come off first, and then the next level, and then the next level, and the next level. They just continue to heat it until they eventually get all of the different components out. So this is different dyes here. You can kind of analyze this, and I have, this is the I do, and you can go back and kind of look at this weekend when you're doing your homework. Okay? So those are the notes for today. I didn't take too long for